Welcome back, everyone, for another deep dive. Today, we're going to be talking about calculation engineers.
Yeah, it's a really interesting field.
So, for someone who maybe has never heard of this type of engineer before, how would you describe what they do?
Well, they basically use computer simulations and mathematical models to predict how structures and systems will behave in the real world.
So, they're kind of like, I'm trying to think of a good analogy.
Uh-huh, no worries. It's a unique field. Some people might say they're like digital architects, but instead of designing the look of a building, they're ensuring its safety and stability.
Okay, I like that. So, they're the ones making sure that a bridge can actually withstand the weight of all those cars, or that a plane wing can handle the stress of flight.
Exactly. They're kind of like detectives in a way, using data and equations to uncover potential weak points or design flaws before they become real-world problems.
That sounds like a job with a lot of responsibility. What would you say are some of the most important skills for a calculation engineer to have?
Definitely a strong foundation in engineering principles, physics, and math. They've got to be comfortable with things like calculus, material science, that kind of thing.
Right, because those are the fundamental laws that govern how things work in the real world, and they're using those laws to create these virtual models.
Precisely. And beyond just the technical skills, they also need to be good problem solvers,
Mm.
critical thinkers, because these simulations can get really complex, and often there's no easy answer.
So it's not just about plugging numbers into a formula, it's about really understanding the problem and coming up with creative solutions.
Absolutely. And let's not forget communication skills, because they often have to explain their findings to people who might not be as technically minded, architects, project managers, clients.
So they need to be able to bridge that gap between the technical world and the real world, translating those complex calculations into something everyone can understand.
Exactly. Now, if we were to actually peek into the workday of a calculation engineer, what would we see? What are some of the tools and software they use on a daily basis?
Yeah, give us a glimpse behind the scenes.
Sure. So one of the most important tools they use is something called finite element analysis, or FEA.
Okay, stop right there. I've heard that term before, FEA, but I'll admit I'm not entirely sure what it is. Could you break it down for us?
Of course. It's basically a way to break down a complex structure, like a bridge or a car chassis,
Yeah.
into thousands or even millions of tiny elements.
Okay, so they're taking something really big and complex and breaking it down into these tiny little manageable pieces, but then what?
Right. So then they use software to apply different forces and stresses to those tiny elements, kind of like a virtual crash test, to see how the overall structure will respond.
So they can simulate things like wind loads on a skyscraper or the impact of a crash on a car all within the computer.
Exactly. And the software analyzes how each of those little elements is affected, which gives them a really detailed picture of where the stress points are, where the weak points might be.
So it's like having X-ray vision for structures, but instead of looking for broken bones, they're looking for design flaws or potential points of failure.
That's a great way to put it. This is just one example, of course. They use a whole suite of software and techniques depending on the specific project, but FEA is definitely a cornerstone of what they do.
This is already blowing my mind, and I feel like we're scratching the surface. But it does make me wonder, with all this emphasis on software and simulations, are calculation engineers turning into these solitary figures hunched over keyboards all day?
Not necessarily, no. Actually, collaboration is a really important part of their work.
Oh, interesting. I guess I just pictured them kind of off on their own in their own little world of numbers.
I can see why you think that, but in reality, they have to work really closely with other engineers, designers, sometimes even clients. They're kind of like translators in a way.
Translators, how so?
Well, they take these complex calculations and simulations, and they have to communicate those findings in a way that everyone involved in the project can understand.
Oh, right, because not everyone speaks the language of finite element analysis.
Exactly. So they might be talking to an architect one minute, explaining how wind loads might affect the design of a building, and then the next minute they're talking to a construction manager about how to reinforce certain structural elements.
So they need to be able to speak both languages, the technical and the practical.
Yes, precisely. And that requires strong communication skills on top of all that technical expertise.
Makes sense. So, we've talked about the skills, the tools, the collaborative nature of the work, but what about the challenges? What are some of the toughest parts of being a calculation engineer?
Well, like you mentioned earlier, it's a high responsibility job. The calculations they make can have huge implications for safety, for the environment, even for budgets.
So the pressure's on?
Yeah, you could say that.
Hmm.
And on top of that, the field is constantly evolving. New technologies, new materials, new software. It's a lot to keep up with.
Right, because you can't just be an expert in what's current, you have to be anticipating what's next.
Exactly. And that means being a lifelong learner, always seeking out new knowledge and skills.
Speaking of skills, let's say someone is listening to this and they're thinking, this sounds amazing. I want to be a calculation engineer. What does that path look like? What kind of education and training do they need?
Well, first and foremost, a strong foundation in engineering is key. Typically, a bachelor's degree in a relevant field like mechanical, civil, or aerospace engineering is a must.
Okay, so no shortcuts there. You got to put in the time to learn the fundamentals.
Nope, no shortcuts. But then, depending on their interests and career goals, they might specialize further, maybe a master's degree or a PhD if they want to go into research or academia.
And I imagine there are also a lot of industry-specific certifications that can give someone an edge.
Absolutely. Things like becoming a certified welding engineer or a certified reliability engineer, those can really demonstrate expertise in a particular area.
So it's about building that strong foundation and then continuing to add layers of knowledge and skills throughout your career.
Precisely. And don't underestimate the value of hands-on experience, too. Internships, co-ops, even personal projects where you can apply your skills to real-world problems. Those can be incredibly valuable.
So not just textbook knowledge, but actual real-world application.
Exactly. It's all about bridging that gap between theory and practice.
This has been incredibly insightful. We've covered a lot of ground here, the skills, the tools, the challenges, even the educational path. But before we wrap up, I want to shift gears just slightly and talk about the bigger picture. Why does understanding this field, even if you're not an engineer, even if you're never going to design a bridge or a plane, why is it important?
That's a great question. And, it's something that I think about a lot because on the surface, it can seem like a very specialized field.
Right, like, okay, that's cool that someone's making sure those bridges don't fall down, but how does that affect me directly?
Exactly.
Hmm.
But the reality is, calculation engineers are involved in pretty much every aspect of our modern world.
Really? Give me some examples. How about, let's say, transportation?
Okay, yeah, transportation is a great example. So, think about the cars we drive, the planes we fly in. Behind those designs, there's a whole team of calculation engineers who are making sure those vehicles are safe, fuel efficient, that they meet all those environmental regulations.
Oh, okay. That makes sense. It's not just about, like, will this car fall apart if I hit a bump? It's also about, like, how can we make this car as aerodynamic as possible so it uses less gas?
Precisely. They're optimizing for all of those factors, and it's all happening behind the scenes. And it's not just vehicles either.
Okay.
Think about infrastructure, things like bridges, tunnels,
Yeah.
dams.
Oh, yeah. Those massive projects that we kind of take for granted, like, we assume that bridge is going to stay up, but someone had to make sure of that.
Exactly. And those calculations they do, they don't just impact whether something gets built, they also influence how much it costs, how long it takes to build, all those factors.
So they're kind of like the unsung heroes of our built environment. They're making sure things are safe, efficient, cost-effective, all that good stuff.
Exactly. And their role is only going to become more important as we face these, global challenges like climate change, population growth.
Right, because we're going to need even more innovative and sustainable solutions going forward.
Exactly. And those solutions are going to require a lot of very careful calculations. So even if you never actually become a calculation engineer yourself, understanding what they do, how they think, it gives you a whole new lens through which to view the world around you.
It's like having a secret decoder ring for understanding how things work.
Yeah, I like that.
Well, I gotta say, I've learned a lot in this deep dive. It's been fascinating to peek behind the curtain of this often overlooked field. So for our listeners out there who are maybe intrigued by what they've heard, who might be thinking about a career in calculation engineering, any final words of advice or inspiration?
I'd say if you're passionate about STEM, if you love solving problems, if you're curious about how things work, then this could be a really rewarding field for you.
It's challenging, but ultimately very rewarding.
Yes, exactly. And, it's a field with a lot of growth potential, especially with the rise of, things like artificial intelligence and machine learning.
It's like the future is being built on a foundation of calculations.
In a way, it is. So if you're looking for a career that's both intellectually stimulating and has a real-world impact, then calculation engineering just might be the perfect fit.
Absolutely. Well, on that note, we'll wrap it up here. A huge thank you to our expert for joining us today and sharing your insights.
It's been a pleasure. Thanks for having me.
And to our listeners, as always, thank you for joining us on another deep dive. We'll see you next time.